Hello everyone, welcome to our channel. Today we have the second video for the kinematics series on how to solve the kinematics equations. The first video was about the 1D questions and how to solve any equation in the x direction. I encourage you to watch it before this one. Today we have the 2D equation problems, which is in x direction and y direction. So let's get started. Our question that we have today is the quarterback Q throws the football when the receiver R is in a position shown, which is the 30-yard. The receiver's velocity is constant. Velocity is constant at 10 yards per second, and he catches passes when the ball is 6 feet above the ground. So we have 7 and he catches from 6 feet above the ground. If the quarterback desires the receiver to catch the ball 2.5 seconds, which is the time after the launch instant shown, determine the initial speed, V0, and the angle theta required. Okay, I encourage you to stop the video, try to do it by yourself, and then continue the video. Alright, so let's get started. I would love, once I start any question, just write down the given that we have. So as I say, velocity is constant. That means a lot. That means acceleration is equal to 0. Any constant velocity, that means acceleration is equal to 0. And give it to you. Let's call it VB, 10 yards per second, 10 yards per second. But I want to change the yard to feet. If I have feet, so anytime you want to change yard, 1 yard equal 3 feet. Okay, so here VB equal 10 multiplied by 3, 30 feet per second. Okay, what else? He said YF, which is this distance they catching the ball from, is 6. A Y initial, we have it already, equals 7. And he gave us also the time 2.5. And here I can change this one to make it 90 feet. Okay, so we try to get the ball here after the 2.5 second. Okay, so let's get started. I would like to start with the x direction, x-axis. Alright, so we try to get the delta x, which is all the distance after also throwing the ball. So I have this one plus this one. So what does that mean? So this delta x equal xi, that is xi, plus vbt. Okay, think about vbt is meters per second multiplied by second. So that is the distance, this distance. Okay, so delta t equal vi, which is 90, plus vb, which is 30, multiplied by 2.5. Okay, if you calculate that, delta x will be 165 feet. Alright, now we can start to solve the equation by the kinematics equation. I will write down the kinematics equation. I will get choose which one you would like to use. The x equal plus half a t squared, v final squared equal v initial squared plus 2as. Okay, that is the three kinematics equations. you can use any one of them to solve the equation. So you have delta x, you don't have vi, because v node there is gonna be v node cosine theta, that's in the x direction, and here v node sine theta in the y direction, and that's what you try to get. You try to get v node and you try to get sine theta. Okay, so I'm saying to choose the second one. Okay, because we have time, we have x, and acceleration is equal to 0. So this one will be really good for us. So delta x equal v naught t plus half at squared. As I say, acceleration is equal to 0, so all of that can be cancelled. So delta x equal v naught cosine theta, this one, multiplied by t. So v naught cosine theta equal kind of divided by delta x, t, which is 2.5. Oh, my bad. 1 delta x divided by t, 165 divided by 2.5, which is equal 66. Okay. So let's get v node by itself. V node equal 66 cosine theta. Okay, that is the first equation that we have. Okay, let's get the y direction. Now we have two unknowns. When it be two unknowns, we need two equations, and we have, as I said, there's a 2D problem. So let's get the y direction, y-axis, and we kind of gonna use the same equation also, because as I say, you're looking about the one that can help you a lot. You have the v node, and we'll have all of the others given. Okay, if you don't know, it's gonna be kind of different. So y final equal y initial, which is delta y, plus v node, let me write it down, v node sine theta t plus half. Now we talk about the y direction, and it will be the gravity, which is negative 32.2 feet per second squared. 32.2 feet multiplied by the second squared. Okay. Yeah, I put some letters and some numbers. Let's fix this thing. Okay, so we said y if it was 6 feet equal 7 feet plus v naught sine theta 2.5, that's time, plus make it minus half 32.2, I just get the negative outside, multiplied by 2.5 squared. Okay, so if you want to get v node squared, you just basically gotta go take this, all of the stuff to the other side, and you divide it by 2.5. So let's get it by the calculator. Or v node sine theta equal 6 minus 7 plus half 32.2 multiplied by 2.5 squared over 2.5. Okay, if you did it by the calculator, v node sine theta equal 39.85. Okay, and that is the second equation that we have. Okay, let's put that both of them together. But what 1 and 2. Alright, so it will be 66 cosine. I'm removing v naught and put the same cosine theta multiplied by sine theta equal 39.85. Sine over cosine is tangent, so tan theta equal 39.85 over 66. So now we can get theta that is required. Theta equal tan inverse 39.85 over 66. So theta equal 31.12 degrees. That is the first given. Okay, and it's really easy to get also the v naught. You basically, if that is 3, but 3 and 1, so v naught equal 66 cosine 31.12. So v naught equal 66 over cosine 31.12, 77.09 meters per second. Right, and that's all what I want. If you have any question, please don't hesitate to reach out to me in the comments, and I will be happy to answer your questions. Please subscribe in our channel so you can get all the updates about the videos that we're doing in the kinematics and the other stuff related to physics, mechanics, statics, dynamics, more for the college level, but also can work for the high school. So see you then.